stuff like that, and then playing them off of it, so you can access the files relating to the game, like textures and stuff like that.
Gotcha. All right, it is 1:01, and I am going to get started. Do you guys want the speaker, the loudspeaker, or not?
Yes.
Yes? Okay. Why?
It's easier to hear.
Easier? Okay, that's good. Good enough. Okay, I did make a separate video on tracing question number 4 of the practice exam. So I'm gonna point you to the YouTube video, because that's something that you guys can watch on your own. So in class, I'm gonna use another example. So this way, it gives you guys more exposure to how to trace a program. And remember, in this class, I'm not going to hold you guys, accountable to the method of tracing, because we all have different ways of tracing algorithms. And somebody messed around with this. Okay. They crank up the gain, even when there's nothing connected. Okay. See. Is that good? Too loud? Too soft?
Okay.
Just about right. Okay, all right, great. Okay, so the first thing I want to do is to go to YouTube, the usual place where you find my stuff is some profs. And I uploaded something that I recorded at home. So this is not something that I did in class, but it is recorded at home. It is, oh, don't tell me I forgot to upload it. It's on the same day as this one here.
The 360A?
Yeah, there you go, 360A, thank you. So this is a new recording. It just illustrates how to trace the program in question number 4 of the practice exam. I use a spreadsheet to do it. Obviously, that's just some way to do it. You do not have to use a spreadsheet. All you need is just a graph paper. Will do nicely because you just need to line up vertically and horizontally. You can magnify, and I think the resolution is actually pretty good. I recorded it using the original resolution, so I know it doesn't look. It looks kind of fuzzy right now, but if you give it some time, I think it will catch up and actually start to improve the resolution. It should be completely readable. Oh, right there. So it's a lot more readable now. The voice should be there as well. Let's see. Oh, I got it turned off. And okay. Volume control, output. Nope. Uh-oh. Did I forget to turn on the mic when I recorded that? I might have. Sorry?
You didn't say anything to the board.
Say again?
You didn't say anything to the board. Forget.
So I might have forgotten to turn on the mic, so it's all kind of, it's a silent movie at this point.
No, your voice recording, I'm listening to it right now.
Sorry?
You recorded your voice, I'm listening to it right now.
Oh, okay, thank you. So it's just my configuration here that is not oh, I know why. Because I keep it here just so there we go. Because there's a mixer here to mix my wireless mic with the output from the computer, and I forgot to turn on the computer input. So, all right, so this is all good, but this is not the one that I'm going to go over today in class. I want to go over factorial in a recursive way, because I think that one will help illustrate most, if not all, of the concepts that you need to understand for understanding recursion, for one thing, and also understanding how to trace the execution of a program when you only have a piece of paper. Okay. All right, so let's go ahead and start with that one. I haven't done this for a long time because a long time ago I taught cisp360 and sometimes two sections in one single semester. But since then I have moved on to this class and the other classes, so this is something that I haven't really done for a while. And I certainly have not done it using C syntax. Okay, I used pseudocode syntax before, but now I can use C syntax. So let's go ahead and I'm just going to write the subroutine here. I'm going to use regular C syntax in this case. This is the prototype or the beginning part of a function. The function name is f. There's one single parameter n. It is passed by, is it passed by reference or passed by value? Value. It's passed by value because it doesn't have the ampersand in front of the variable name. And how many people remember the Factorial program? I'm going to do it the long way first, okay, which is easier to trace, and then we'll try to do it in a shorter way and a shorter way, okay? All right, so the longer way, I'm going to use a local variable r to remember what the result is supposed to be. So I'm separating the return statement from the line that does the recursion, because that is where the confusion comes in, okay? That's one major source of confusion. So I'm not going to do that part, to make it confusing. I'll use a regular conditional statement instead of a ternary operator to further reduce any type of confusion, before we fully understand, how to trace algorithms like this. If n is less than or equal to 0, and we say r equals to 1, because, n factorial is 1 if n is less than or equal to 0. Otherwise, r is n times the factorial of n minus 1, like so. End of the else case, return r at the very end of this subroutine, close the entire subroutine like that. Okay, and now we can start the execution from main itself, int main. And inside main, I can make my own local variable. Let's say, that's x. And then we can say x equals to the factorial of, I don't know, 3 is good. Well, maybe 2. Okay, 2, I don't know, 3 or 2. 3, okay, there we go. All right. Okay, do you guys want me to trace this program without indentation, or do you want me to put in indentation first?
Indentation.
Indentation first. Okay, very good. Because when I was grading your homework assignments, there were a few submissions that were without indentations whatsoever. Which I found kind of interesting because indentation is extremely helpful when it comes to understanding the structure of the program. Without indentation, it becomes kind of hard to find out, where's the beginning of the conditional statement, where's the end, and stuff like that. So even though it's not required, I think it is a good idea to use indentations whenever it is possible. So in this case, I am going to use the correct indentation so that we can indicate how statements are nested. So this way we understand the structure of the program a little bit better. It's more visual, like so. Is that better? Sort of? Okay. All right. So in column A, I usually just use it for line number, and line numbers are pretty easy to do in a spreadsheet. All you have to do is to drag the little cross symbol down, and it automatically renumbers. All right, so this is the whole program. Are there any questions about the algorithm itself, the C++ program? Any questions about the conditional statement? There should be nothing really too special. The only thing that is tricky about this program is the recursion. Okay. All right. So with this one here, I'm going to start a new sheet for the trace, and I'm going to open this one in a new window. Let's see. With this type, with LibreOffice, and also I think you can do this with Excel as well, is you can open up multiple views of the same document, and one view I use it to view the program itself, and then the other one for the trace itself. So that's why I'm switching the. I want to get rid of this one here. Can I get rid of it? Close sidebar. There we go. I'm trying to maximize, how much screen space I have for the trace because it's going to take a lot of space. All right. What is the first line that I'm supposed to execute in this program? Remember, the program is on the right-hand side. What is the first line that I should start with? It's the first line that does something in main, and that would be line main, in main.
16.
Okay, 16 is the first line in main, but it doesn't do anything, okay, because it's just a declaration of a variable. So I don't really do anything about that. But I do have to do one thing because I don't know where to go back to as far as main is concerned. But we know that x is a local variable of main, so we have to allocate one column for x. Now I usually allocate 2 more columns to the left-hand side. So let me just insert those 2 columns. One column is called line number. Okay, line number is basically just indicating on which line what are we doing. Okay, that's the line number column. This column here is called comments. It indicates, it records stuff that we need to know in order to understand how the program executes. It's typically used when we have conditional statements or loops, when we evaluate a condition so that we can decide whether to get out of the loop or stay in the loop. I use the comments to indicate the result of the expression. Okay, so it's for stuff that does not have any actual effect on the other columns, but it does alter the path of execution. So on line, well, I guess you guys can say on line 16, we allocate a column, which is column C, and we give it an unknown value because this is just a local variable. All variables in C start with unknown values unless you use an initialization along with it. Then the next line is line 17. Now line 17 is interesting because line 17 is an assignment operation. We know that because of the single equal symbol here, but I cannot perform the assignment operation yet until it is coming back from the invocation of f. Is that making any sense? Because that the invocation of f with a parameter of 3, with an argument of 3, is what we need in order to figure out what value we want to store into x. So the first thing we want to do is to say, well, we cannot do the assignment just yet, but we can call f with an argument of 3. Is that okay so far? So every time we call a subroutine, or every time we invoke a subroutine, in this particular way, I have a very specific way to represent an invocation. An invocation has multiple parts. The first part is called the return info or return line number sometimes. Return info is basically indicating when the invocation is done, what am I supposed to do next? Okay, because when the subroutine is all done, you have to know, okay, I'm at the end of the subroutine, where am I supposed to go next? What am I supposed to do next? So return info is the sole purpose of column D, which is return info in this case, is to help us remember what else do we need to do when we come back from the invocation. Are there any questions about the purpose of column D? Okay. But how do we record that? Because when we're done, we are not going to move on to line 18 because we still have something else to do on line 17. So the way I record it is to indicate we have to come back to line 17 because there's something else to do on line 17. So what do you think we need to do when we come back from the invocation of f with an argument of 3? What else do we need to do on line 17? If you think about the ordering of operations on line 17, the first thing we need to do is to figure out the return value of the invocation of f with an argument of 3. What is the second thing we have to do on that line? The assignment operation, use the value returned by f to change x. Right? That's the second operation. We cannot do it just yet. We have to do it after we come back from the invocation. So the way I record that is to replace the invocation itself. The invocation of f with an argument of 3 is not replaced by a single question mark. It is a placeholder. It's a placeholder so that when we execute a return value statement in f, we know, okay, that question mark now has a value. So the question mark is a placeholder of the return value of f. Are there any questions at this point? Because this is really important. If you have any questions to ask, ask now, because I want to make sure that you guys understand what we are doing with this trace. No questions? Okay, well, you can always ask questions a little bit later, but ask those questions as soon as you can. Okay, we can allocate additional columns for any type of parameter and also local variable. We also use additional columns. In this case, we do have one argument or one parameter. It is n. And what do you think is the value of n as a parameter? On line 17, did we specify the value of parameter n?
No.
Are we passing in 3?
Yes, we use 3 to specify the parameter n. So n has a value of 3. And we also have a local variable called r in the subroutine. But because it's a local variable, it starts with an unknown value. So I use a question mark in this case to indicate it is not known at this point. So what I'm doing here is I'm just shrinking the width of the column so I can fit more stuff on the screen. Okay, so when remember what we talked about, subroutines are, you have to understand subroutines on a per invocation basis, how local variables and parameters are on a per invocation basis. This makes it very clear, because when you look at columns D, E, and F, those are all allocated on a per invocation basis. When we call the subroutine, those 3 columns will be allocated. When the subroutine returns, those 3 columns will be gone. Is that okay? Are there any questions about those 3 columns? Because this is very significant. And then we continue execution in the subroutine. Okay, line 3 doesn't do a single thing, so I don't really trace that. But line 4 does something, because line 4 is the beginning of a conditional statement. We have to decide, okay, do we go for the then or do we go for the else? This is when I use the comments column and indicate n is less than or equal to 0 is either true or false. What do you think? Is it true or false at this point that n is less than or equal to 0? It is false because n has a value of 3. 3 is less than or equal to 0 is false. Then where should I go to continue execution? Okay, some people say line 8, but line 8 really doesn't do anything. Line 9 doesn't do a single thing. So I would just skip those 2 lines and go straight to line 10. So when we get to line 10, you say, well, we have to call f again in order to finish the multiplication. And then after we finish the multiplication, then we can actually do the assignment operation. Is that making any sense? The ordering of what we need to do. The first thing we have to do is to call f with n minus 1 as the argument, because otherwise we cannot finish the multiplication. If we don't finish the multiplication, I don't know what value I'm supposed to use to update r. So the first thing we have to do is to call f again. Okay? And do you remember what we're supposed to do every time we call a subroutine? Several things to do. Okay, we have to allocate certain columns on a per invocation basis, and then we continue execution at the beginning of the subroutine. What type of stuff do we keep track of on a per invocation basis? Yes?
The value of n?
The value of n is one of those, but we have 3 things. The first thing is what?
The return.
Return information, because we need to remember when this invocation, the second invocation of f is done, where am I supposed to go back to, and what else am I supposed to do on that line? So the return info cell, or column G in this case, is keeping track of that information. So tell me, which line am I supposed to go back to when f is done on line 10?
Supposed to go back to line 10.
It's supposed to go back to line 10. Very good. Because on line 10, there are a few things that we still have to do, including the multiplication and also the assignment operation. But remember, I use a question mark to replace the invocation itself, because the question mark is a placeholder of the return value. It is a place to say, hey, when we get the return value, this is where it's supposed to go. Okay? Now, sometimes I forget the semicolon in terms of syntax is not important in this case, because we are focusing on the flow of the program, not so much the syntax in this case. All right, well, but as you said, we also have two more things to track. One is n, and the other one is r. Now, what am I supposed to put here as parameter n?
2.
2, and how do we know it's 2?
N minus 1.
Because it's n minus 1. Now, it is confusing because, well, if this is n minus 1 and this is also n, which n are we talking about? We are still currently, n as far as we are concerned, is still this particular column. This is the new n, okay? So the new n is the old n minus 1. So n minus 1 is 2, and then we use that 2 to specify the new parameter 2 for the next invocation. The new invocation is not done yet, okay? We're still setting up everything. R is always unknown because it is a local variable. So right now, we can clearly see that we have two separate invocations of f. Columns D, E, F correspond to the first invocation. Columns G, H, I correspond to the second invocation. So this is what I said when I told you guys, like, early, well, not early, but kind of early in the semester, that local variables and parameters are on a per invocation basis. This is what I meant by that, okay? Are there any questions at this point about the spreadsheet? No? No questions? Okay. Now that we have remembered where to go back to, we have set up all the local variables and parameters for this new invocation, we can actually go into the subroutine now. And where am I supposed to start when we call a subroutine? The first line that does something useful. So in this case, which line? Line 4, very good. But we have been to line 4 before. It doesn't matter, okay? Whenever you invoke a subroutine, you always start from the very beginning of the entire subroutine. It doesn't matter this is recursive or non-recursive. When you call a subroutine, you start from the beginning. All right, on line 4, we have n is less than or equal to 0. It is still false because n is 2 in this case. And we move on to line 10 as a result. And you can see this is going to get a little bit boring because on line 10, guess what we have to do? We have to call f again, but this time, okay, I'm going to do another trick here, okay? This is also a really nifty trick. It allows you to slide certain portions of your spreadsheet to expose only a certain portion and then keep the other portion hidden at this point, okay? But this n is going to be 1 because 2 minus 1 is 1. So for the third invocation, n has a value of 1. Once we set up these 3 columns, we continue execution inside the subroutine from the beginning, which is line 4 again. N is less than or equal to 0 is false because n is 1 in this case. Yep, go ahead.
Just a little off topic. This example problem is supposed to be like a problem from exam 2, right? Similar to the problems we'll encounter in
No,
exam
this
2.
is like something that we talked about a long time ago.
Right, that's what I was wondering.
Yeah.
Are we going to have questions like exam 1 on exam 2? I know that's kind of hard to answer, I guess.
It is not possible for me to have questions that do not involve topics from before exam 1.
So we're going over why we're going over this. Does it have to do with exam 2? I mean,
Yeah.
yeah.
Yeah, because one of the questions in exam 2 is recursive, and this is telling you how to trace, programs in a recursive way.
Okay.
Yep. All right. So on line 10, we do exactly the same thing as before because we have to call f again, and this time, n is 1, so n minus 1 is 0. So the new invocation, this is the 4th invocation of f. N is going to be a 0 in this case. So let me just shrink the columns. And then we continue execution in the subroutine starting on line 4. Line 4 is still asking the question, n is less than or equal to 0. This time it is true, okay, because n is 0 in this case. Okay, I have been waiting for someone to ask this question, but since no one asked, I'm going to ask it myself. How do we know which n and which r we are dealing with? There are 4 n's at this point. So how do we know which column we are actually trying to access when the algorithm calls for n? What do you think?
Track the frame.
Do a last
The last one, exactly. It is the rightmost one that we are referring to. Okay, very good. So it's the rightmost one in this case. So when we refer to n, we are referring to column, well, coincidentally n. Okay, but it is the rightmost version of n. Okay, all the other n's, like in columns, column K is not accessible at this point. Okay, we can only access the most recent invocation. All right, very good. So because line 4 has the condition being true, we are not going to go to line 10 this time. We're going to line 6. Line 6 doesn't do a whole lot, of stuff. Okay, all it does is to change my local variable r to 1. So local variable r is now 1. Yes, go ahead.
Could you have decreased the number of invocations needed if you would have put if n equals 1, r equals 0? That way it returns 0.
You can change
and that way
n
you
is
don't
less
have,
than or equal to 1, yes.
and then r equals 0.
But that's
that
not the
wouldn't work.
definition of factorial.
It wouldn't.
The definition of factorial is 0 factorial is 1.
Okay, what I mean is, aren't you going to have to, when this comes all the way back, 1 times 1 equals 1, so
Yeah.
isn't that kind of redundant? So couldn't you
Sort of.
you could remove a frame by putting n equals 1 and r. Oh, you're right, because it would have to.
Well, I
it
mean,
couldn't
this
be
is
0.
more. This is closer to the actual mathematical definition of factorial.
But it is possible to switch those two to bring less invocations.
Yeah, we could.
Good.
Yep. Go ahead.
If you would have, in line 1, sent n by reference, like if you would have put a ampersand in there, would it have just recursively, like, for
Well,
n
that would
at
be
point?
kind of. It wouldn't work because if you change n to be passed by reference, this would not. This cannot work.
Right, because if
It
you
doesn't
pass-
have a place to store.
If you pass by value, that's how it knows to go to the lastmost one, correct? The rightmost one?
We can do another example with passing by reference, so I can show you, what it looks like when we have pass by reference. But passing by reference means you're just passing the reference along, okay? So they will all parameters n will now be referring to the same thing, the same column eventually. Okay. Yep.
How could you pass by reference? In order to pass by reference doesn't have to be assigned a value, or can it pass by reference even when the
In this
value
case,
is
we cannot pass by
uninitiated?
reference because n minus 1 does not act. It's not a variable. 3 is not a variable, so I would not be able to pass by reference in this case. It's not entirely true because if I say const int and we can actually pass it by reference, but it's a really weird case. I'm not gonna talk about that in this class. So we'll just say that we cannot pass by reference when the expression is not just a variable. Okay. All right. So after line 6, where do we go? Now this is the other great thing about tracing on a piece of paper is I can go now, to make a cup of coffee and then come back and I know exactly where I left off because I can see that, row 16 of the spreadsheet is the very last thing that we did. So now I have to say, okay, after line 6, where do we go? What do you think? Line 6 is the only thing inside the then branch of the conditional statement. So what do we do after the then branch of the conditional statement? We go to the return statement. Very good. We go to line 12. Okay, so we go to line 12. Now this is also a very important moment. I'm kind of sorry that he is not here for the important moments, but this is one of the most important moments because the return statement is the one that will change the question mark to an actual value. Because remember, what was the purpose of the question mark in return info? It's a placeholder, right? It's a placeholder of what? It's a placeholder of the return value of an invocation of a subroutine. How do we specify the return value of an invocation of a subroutine? The return statement, okay? So on line 12, which is what we're going to execute now, we are specifying the return value of the last or the fourth invocation of f, okay? And if you look at line 12, what is it returning? What is the value that it is returning? It's returning whatever r is, right? And r is column O, and what is the value of r? It's 1. So what we do, okay, is just copy and paste this cell here, and change this question mark to whatever value we are returning, just 1. Now, don't do any simplification, okay? At this point, don't look at this and go like, oh, n times 1 is just n, let me just simplify to n. There's no need to do anything like that. All we do is to change the question mark to the value that we are returning, and we don't do a single thing about line 10 at this point. This is not the time to do anything about line 10. Are we doing okay so far with that? Okay, because we are executing line 12, which is going to affect line 10 when we get back to line 10, but we are not on line 10 just yet. Do we have any questions about this step here? Because this is really, really one of the most important part of tracing a subroutine execution. No questions? Okay. Well, it's okay. We'll see this many times. Okay. In this particular example, we'll see it many times. After line 12, technically, we go to line 13. Now, line 13 has significance because it is the end of the entire subroutine. Just like when we invoke a subroutine, we allocate the 3 columns, in this case M, N, and O. When we exit or when we return or get out of a subroutine, we have to remember to deallocate the very same columns. So this way, those columns can be reused later on for additional invocations. Because otherwise, we'll just keep using more and more columns. Okay, we don't want to do that. Okay, we don't want to be wasteful. So we want to reclaim the space of an invocation of a subroutine that is now ending. So on line 13, the way I represent that is to basically copy and paste the same 3 cells over here, except I would use format cells, go to font effect, and then use a strikeout effect to indicate that these columns are now deallocated. This part is a little confusing because where am I supposed to go now? After line 13, where am I supposed to go? Well, something was helping me to keep track of where to continue execution. What was it? The return info cell, right? So the return info cell of row 17, okay, look up row 17. This return info cell is saying, okay, go back to line 10. Okay, I'm going back to line 10, but what am I going to do on line 10? Well, finish it up. Because on line 10, now I know the return value of the subroutine is just 1. So the whole thing becomes R is n times 1. But which R are we talking about? Which n are we talking about? Not columns n or o anymore, because these are now deallocated. When we get back onto line 10, columns m, n, and o, they're all deallocated. They are still there, but we are not going to use those. We are now going back to columns j, k, and l, which means n is referring to column k, and r is referring to column l. Are we doing okay so far with that? Because we have changed the context. The last invocation, the 4th invocation, is now done. We're back to the 3rd invocation, which means columns j, k, and l are the ones that are in effect at this point. Is that okay? All right. Okay. So n is 1. N 1 times 1 is 1. So this r is going to get a value of 1 when we execute line 10. After line 10, where do we go? Line 10 is the only thing we do in the else branch of the conditional statement. What do we do after the else branch of this particular conditional statement?
Go back to the previous invocation.
Not yet. We get out of the conditional statement. What is right after the conditional statement?
Return R.
The return statement. Very good. Okay, so the return statement is on line 12, and just like what we did last time, when we execute the return statement, we use the return info cell, just copy and paste it. Change, oops, I did not do the copy and paste to the wrong place. Okay, so we copy and paste it, and then we replace the question mark, which is the placeholder of the return value, with the actual return value. What is our return value this time? What is R? R is column L, and column L has a value of
1.
1. Very good. Okay, so we just, oops, We just replace the question mark with a 1, and once again, we do not simplify anything. We don't do a single thing. We just replace the question mark with the value that we're returning, and we don't do a single thing after that. After line 12, we go to line 13. The significance of line 13, once again, is it is the end of one invocation. We got two things to do when we're at the end of an invocation. First thing first, deallocate the columns. And then we use the return info cell, which is actually deallocated at this point, but they kind of happen at the same time. And then we use the return info cell to tell us where we are going to continue execution. This tells us to continue execution on line 10. But it's more than just that. It's more than just which line we're going back to, because when we get back to line 10, we don't have that question mark anymore. The invocation is now replaced with a concrete value of 1. Okay? And because column J all the way to O are now deallocated, I have to kind of move it along so that we can see columns G, H, and I again. Okay, so on line 10, okay, line 10 we have executed. This is the third time we get back onto line 10. When we get back to line 10, we have to evaluate the way it is specified here. What is N in this case? We have to, okay, we have to refer to the rightmost column with that name. What is the rightmost column with the name of N that is not deallocated, that is still active? Which column are we talking about?
H.
Column H, and column H has a value of
2.
2. Very good. Okay, so great. So now we know that N is 2, 2 times 1 is 2, so R gets a value of 2 as a result. So we put a 2 here. That's the effect of line 12. Line 10. After line 10, we go to line 12. Line 12 is a return statement. And as a return statement executes, all it does is to evaluate the expression, figure out what is the actual value, and then we copy and paste the return info cell, change the question mark to the value that we are returning. In this case, it is R. R has a value of 2, so we change just the question mark to 2. And then we don't do a single thing about line 10. We go to line 13. Line 13 is the end of the invocation. Remember, at the end of the invocation, we have to remember to deallocate all the columns for this particular invocation. And then we use the return info cell to tell us, okay, where am I going now? I'm going back to line 10. But more than just going back to line 10, we have now resolved the function call itself has a value of 2. I know this is a little hard to see because we have scrolled off this already, and I can use the other tool to scroll the other part of the screen. So now we can scroll the top part back to where we need, the bottom part to where we need, and now we can execute line 10. Line 10 says we have to evaluate the product of N and 2. Okay, what is N at this point? What is the value of N? Which column are we talking about? Column E, exactly, because all of the other columns are now deallocated. So the rightmost active column that has a name of N is column E. Column E has a value of 3. 3 times 2 is 6. So we store 6 in R on line 10. So now R has a value of 6. Then we continue execution on line 12. Line 12 is the return statement. We just blindly copy, paste, change the question mark to the value that we are returning, which is in this case 6, and we're done. But we don't do any changes of X at this point. We are not really executing line 17. We're just saying, by the time we get back to line 17, this is what we're going to do. But we are not doing it just yet. Are we doing okay so far with this trace? Sort of? Okay. Then we go to line 13. Line 13 is the end of the invocation, so we have to remember to deallocate all the columns. And then we use the return info cell to tell us where to continue execution. Oh, on line 17, fine, we go back to line 17. But it's more than just going back to line 17, because now the invocation of F is fully resolved. We know it is a value of 6, so we are going to update X with a value of 6. So if I scroll back to here, it is column C. So column C is now finally getting updated to a value of 6 on line 17. And obviously on line 18, we're going to return. When we return from main, I'm not going to do anything. There's nothing really to trace here because we are simply specifying the exit code of the entire program, which cannot be seen in the trace itself. So I would call this the conclusion of the entire trace. Whew. How was that?
That was lengthy.
Hmm?
It's very lengthy.
But did it help? Did it help you guys understand recursion? How the computer was able to track all of these things when you call the same subroutine over and over again? And how it can unwind stuff?
I mean, I'm about where I was before, but I had a pretty good grasp on recursion, so.
Okay, all right. But in terms of the exam questions where you need to track everything and print the values of the variables, this will be helpful. Because at any point, if I have a printf, you just need to look at the columns and go like, oh, okay, this thing has a value of blah, 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 just print it out. Yep.
Do we have to do, say there's a recursive question where you want us to go through the invocations, you're not going to require us to have it in this annotated format, are you?
No, not in this class. But you will have to find your own way of tracking stuff, okay? This is just the way that I would have done it, okay? But however you want to simplify this, it will still have to include the same kind of information in order for your algorithm, in order for your trace to work properly. Yep.
Can we leave out, like, for example, if R is unassigned because it's a local variable, are you going to want us to meticulously put, like, R is unassigned, or can we just update N through the invocations?
I would say just read the question and find out what the question is asking,
All right.
because it depends on what the question is really asking. So I'm going to go back to the questions in exam 2. I call this a practice exam, but it really is the exam from the previous semester. But it doesn't really say anything about what your exam is going to look like. I'm not saying that in a malicious way. I'm just saying that so that I won't be held accountable and say, but the previous exam looked like this, and our exam did not look like that at all. All right, so this is the previous exam, and this is a good example. Okay, so whenever you have a printf, you have to tell me what that printf is going to print. Okay, so you have to answer the question the way it is asked. If x and y has not changed the value from the previous time, you still have to print it out. Okay, because I'm looking for an exact trail of how the variables got changed on those particular lines. Okay, so let's take a look at this one here. When we execute this printf, does it say anything about R? No. So that means you don't have to say anything about R. In fact, it would be wrong if you tell me what is R at this point, because the algorithm, the program did not ask you to print that. When we get to this line here, it only asks you what is the value of R at this point. Does it ask you about the values of X or Y? No. So if you tell me what is the value of X and Y at this point, it would also be wrong. Because I want you to execute the program the way the computer would have. Yep.
On printf, when it says x equals %d, the x and y parameters on the far right hand side are what's x is going to equal, correct?
Correct.
Okay, and then what's that /n?
\n?
Yeah.
Well, we explained that in your very first program. It's the line feed character. That's how we break a line. Okay, so the placeholders are the two %ds. The first %d is going to be filled in by the value of x. The second %d is going to be filled in by the value of y. %d means it is base 10 signed. Okay, this \n is the line feed character. Otherwise, everything would appear on the same line. It will be extremely difficult to read. So that's why we have the \n here. But everything else, you just print it the way it is specified here, verbatim. So x equals to is just x equals to in the output. Y equals to is just y equals to in the output.
So below that, where it says r equals x is greater than or equal to y,
Yeah.
and then you have a ternary operator of true or false.
Yep.
And then, so how would you separate is the r equals x is greater than y, like one side of the operation, or is the whole thing, like the operation equal to r?
You mean when you trace it?
Yeah.
When you trace it, that's a good question. When you trace it, you will basically have to evaluate it and decide whether you are only going for x plus y or whether you have to go for the third expression. If you do go for the third expression, then you will have to use the return info cell, change the function call itself to a question mark as a placeholder and do the entire do the whole thing. Is that making any sense? No? Okay. I will go ahead and change the factorial program, but this time I'll use the much more cryptic way to represent the logic, so that way you can see the kind of really spelled out version and also the kind of more or less confusing version. Yes, go ahead.
So if you do on that ternary operator have to go to the false condition and have to invoke second invocation, r is going to be unassigned and it would just be an r question mark for that
For
first.
the printf?
For the very first invocation of f, r is going to be unassigned if we have to go to the false condition.
No, because it's a ternary operator. The entire expression will return something so that r has a value. This entire thing will come back.
I know. What I mean is so we find out that x is not greater than y. So when if you wanted us to ask what the variables are for each invocation,
No, that's not what I'm asking. Well, you have to track it somehow. Okay,
Right.
that's your task.
R wouldn't be R wouldn't be assigned until we're finished with all the invocations.
That is correct.
So it would be a question mark at this point if it returned false, and we would have to go into the invocation.
That is correct. But you don't have to print it because I did not say anything about printing R.
Yeah.
Okay, you had a question?
Yeah. On the exam 2 practice questions on here, there's one that has a bunch of arrays. I thought you said we didn't have arrays on the test.
That is correct. Arrays will not be a part of the exam. Which one again? Number 2?
The example question 5.
Question 5? Yeah, I took out that question in the practice test. Oh, I did not, I
No,
guess.
it's there in practice.
Okay, so you're correct. We won't have array questions in our exam 2.
Okay.
Yep.
Have you gone over arrays?
Sort of.
Okay. I just have to watch that video.
Yeah, you're missing all the important moments. Okay, so any questions before I use factorial again, but this time we use ternary operators and all kinds of concise way of doing things? Any questions? Nope. Okay. So let's go ahead and take a look at the new one. They're making a new spreadsheet for that. Okay. So int f, int n. Okay, I'm not changing the way that part is represented, but the entire thing has one single return statement because it says something like this: n is less than or equal to 0. If that is true, we return a value of 1. If not, I'm going to use extra parentheses here just so that we know exactly how things are grouped. So we say it is n times the factorial of n minus 1. In other words, I got rid of r entirely because the variable r of f really does not need to be there. I mean, I was putting it there just for clarity purposes, but it really does not need to be there. Okay? So is everybody kind of convinced that this is doing the same thing as the previous program? It's just a lot more concise. Okay. So, but we do want to trace this one, okay, to figure out, okay, if it is like this, what do we do about it? Okay. So we have main, And main can be exactly the same as last time. You know, we have a local variable x gets, you know, same thing, okay, f of 3. And return to 0 here, close curly brace. And you know what? You know, instead of going through all the unnecessary invocations, I'm going to change this one so that it is, if n is less than or equal to 1, then it is 1. So we save ourselves one invocation in this case. Yep.
Why not have it be less than or equal to 2 is 2?
Because in that case it won't catch the factorial of 1.
Okay.
Or 0. Okay, I know that this may not be related to this class, but for those of you who will take cisp 440, this will come back and haunt you. Why are we talking about factorial? What is the purpose of factorial numbers? I mean, we know that n factorial is n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. But why are we interested in the factorial of something? Because we want to make money. That's why. Okay, so lottery tickets, right? So when do you think is a good time to buy a lottery ticket?
Never.
Well, you have to calculate the chances of winning, right? Okay. Well, you don't just say never because, you know, other people say never, right? So you have to calculate the probability of actually, you know, winning the jackpot or winning something. But how do you do that? Statistics, exactly. Fortunately, in California, the government has done everything for us already. In other words, you know, they have spelled out the actual chances of winning each individual prize on the website. Okay, if you go to the California lottery website, they tell you exactly what the chances are. Okay, but do you trust those numbers? How did they come up with those numbers? Well, if you have any suspicion and you want to come up with your own numbers, then you need to understand, you know, how to work with combinations and permutations. And factorial is really helpful when you need to do something like that. It is a very useful function to calculate the number of combinations or permutations when you need to figure out, okay, I got 5 things, how many ways can I choose 3 things out of 5? Okay, those are the topics where, you know, factorial becomes an important topic. And those of you who are in the computer science track, you will take CISP 440, where, you know, when we take a much closer look at factorial combinations and permutations. All right, so getting back to this one here, we are going to trace the other program. I'm going to close this one because we don't need that anymore. Save, no, save. Nah, since the recorder is still going on, I'm not going to save it. Yep, still recording. Very good. And well, I think I just closed the one that I don't want it to close. Yep, I did. All right, that's okay. Oh, it's in sheet 1, so we're still good. Just need a new window. And all right. Now we are ready to trace this one. We have one column for comments. In this case, well, I'm going to use comments. Line number, and we are going to say line 7. Excuse me, that is really distracting.
Oh, I'm sorry. Yeah.
Okay. And if you watch the video, you will hear that too. So on line 7, we are allocating one column for local variable x of main. It is initially unknown. And then on line 8, we have a function call, just like last time. And just like last time, we have to allocate columns for each invocation. The first one that we allocate, that I would use, is return info. Okay, return information. It tells us what we are supposed to do when the subroutine is done. So in this case, we're supposed to go back to line 8 because we still have the assignment operation undone yet, or not done at that point. The invocation itself is replaced by a single question mark as a placeholder of the return value of the invocation. So that's column D. Column E is the parameter itself, which is n. In this case, it is quite clear on line 8 that we are using a value of 3 to specify parameter n. So n starts with a value of 3. And this time we don't have r. Okay, we do not have the local variable r as last time. So once this is all set up, we can continue execution in the subroutine. Well, the subroutine only has one single line, which is line 3. Okay, so this is the first time we get to line 3 of the first invocation. As much as I want to conclude and say, okay, we're returning this value, we're done, let's go home, I can't, right? Because we have to first evaluate the first expression of the ternary operator, and this is where the comments column is going to come in handy, because n is less than or equal to 1 is 3 less than or equal to 1? False. Very good. Okay, so if that is false, that will force us to evaluate the third expression of the ternary operator. The third expression is n times f of n minus 1, which means I cannot do the multiplication until the invocation, the second invocation of f is done and tell me what the return value is. So that means I have to call f again with n minus 1 as the parameter. Yep.
Is evaluating less than or equal to more intensive than evaluating greater than?
No.
Okay.
They boil down to about the same thing. Okay, so on line 3, what are we going to do about line 3 this time? Okay, so you basically say return. Whatever we have evaluated at this point, you can kind of use that. So you can say the first expression is just false or 0 if you will. The second one is a 1, oops, question mark, a 1. And then the third one is the one that we are dealing with, which is just n times a question mark, because remember, we are replacing the invocation itself with a question mark as a placeholder. So that's how we would use a column to represent the return info cell. And then we also have to have one more column to remember what n is. N is now 2 because it is 3 minus 1. Okay, let's compact those two. Then we get back to line 3 because in the new invocation, in the second invocation, we have to start from the very beginning of the subroutine, which is starting on line 3. Same thing here, okay? We first evaluate n is less than or equal to 1. 2 is less than or equal to 1 is false. So we end up doing the same thing, which is invoking the subroutine again. And this is when I can split the screen like this. It comes in handy. Like that. And n is now 1 because in the previous invocation it was 2, 2 minus 1 is 1. So now I have set up the 2 columns. I can now continue execution in the subroutine that we are calling, which is f again. And it only has one line to execute, which is line 3. N is now 1. N is less than or equal to 1 is
True.
True. Very good. Okay, nice. Because if it is true, then we can just return the second expression, which is just 1. Okay, so that means we are actually executing the return statement itself because the expression, okay, the expression of the return statement evaluates to a constant of 1 in this case. So we are just returning a value of 1. And what do we do when we return a value? When we execute a return statement, we look at the return info cell. We copy, we paste, we change the question mark. Well, now this time you have to remember which question mark because one of those is the actual operator, okay? Like this one is the actual operator. We don't want to change that one. So we're changing the placeholder of the function call itself to the value that we're returning, which is 1. Is this step okay? Now, because this time it looks a lot more confusing than last time. Because executing the return statement is changing the return info cell, which is a return itself. Did I do anything differently this time as far as the trace is concerned compared to the previous time? The answer is no, absolutely nothing different. Okay, when we execute the return statement, we just copy and paste the return info cell, change the question mark, the placeholder of the invocation to the value that we are returning, and we're done. Okay? So we are not executing the line 3 that is here, that is highlighted. We are just specifying the return value of 1. And then what we do is we go to line 4. Line 4 is the end of the subroutine. It's got 2 jobs to do. The first job is to deallocate the columns that we have already allocated for this invocation. And the way I represent it here is to strike out. The second thing we have to do on line 4 is to say, okay, but where am I going? According to the return info cell, we're continuing execution on line 3. Okay, fine. But what does line 3 look like this time? Oh, line 3 now looks like this. Okay, because we have fully resolved the function call. It has a value of 1, so the third expression of the ternary operator is just n times 1 this time. But which n are we talking about? We cannot be talking about I because it is now deallocated. So when we get back onto line 3, we have to forget columns H and I because those 2 columns are gone. So now we are getting back to column F and column G. Column G has a label of n. It has a value of 2. Okay. So when we evaluate, let me see if I can do this. So when we evaluate line 3 like this, this n is referring to column G, which has a value of 2. And because it is the third expression of the ternary operator and the first expression has a value of false, we can now finally evaluate the entire ternary operation, ternary expression. It has a value of what? 2, exactly. So we are now returning a value of 2. What do we do when we execute a return statement, knowing the value that we are returning? Come on, it should be boring by now, okay? If you think, oh man, this is boring, you have been doing the same thing the entire class, it's good news. Okay, because this is not different from what I did with the previous program. When we execute the return statement, what kind of boring stuff do we do? Copy, paste, change the question mark, and then move on. And that's exactly what we're going to do here. Copy, paste, change the question mark to the value that we are returning. This is the tricky part. What value are we returning? We are returning n times 1 because of this. But which n are we talking about? Column G, because we are now back to the context of column F and column G. So we are changing the question mark itself to 2 in this case. Are we doing okay so far with that? There's nothing wrong with the return info cell containing a return statement itself. That is not a problem. Okay? And then we move on to line 4. Line 4 has got 2 boring things to do. The first boring thing that it has to do is to deallocate the 2 columns. Okay, so we'll go ahead and deallocate those columns. And then the second boring thing it has to do is to decide where am I supposed to go to continue execution. And according to the return info cell, we have to go back to line 3. Fine, we're going back to line 3. But this time when we get back to line 3, it now looks like this. In other words, the invocation of F is now fully resolved to a value of 2. Well, if we know that the second value of multiplication is 2, we can now carry out the multiplication and actually figure out what value we are supposed to return on line 3. But which n are we talking about? We cannot be talking about G because G is now deallocated. So the context that we are dealing with now is column D and column E. And because we are supposed to evaluate the expression of n times 2, but n is referring to column E in this case, we are now saying, okay, what is 3 times 2? 3 times 2 is 6. So we are returning a value of 6. What do we do when we return a particular value? This time it is 6. The boring stuff. Copy, paste, change the question mark to 6 this time. Do we change x at this point? No, because we do not evaluate, we do not run the statement in the return info cell. We're just keeping track of by the time we get back to line 8, that is what we're going to do. Okay, but we are not doing it now. We go to line 4, same boring stuff, deallocate 2 columns. and then we continue execution based on the return info cell. The return info cell says we have to get back to line 8. Okay, fine, we get back to line 8. And what do we do on line 8? We can now actually finish up the assignment operation because we know the entire right-hand side evaluates to a value of 6. So now we can update x to 6, like so. And then on line 9, it is a return 0 in main, and unlike the other return statements in main, when we get to the return statement, we just say, okay, the program is all done, and that's the end. That's the end of this trace. Are there any questions about this trace? No questions? Yep, go ahead.
Just use one less iteration of the previous format. Is it technically more efficient, or?
Yeah, it's just this much more efficient. Not usually, not by much, not really significant. Are there any questions about the trace itself? No questions? Let me show you one thing, okay? Because I do want to show you this because I think it is kind of important. Unfortunately, you guys do not actually have access to this. Okay. So I go to the intranet. And go to the curriculum services. Does anyone know what is a curriculum, by the way? No.
The outline of the information presented
Well,
in the course.
Yep. Well, actually, it's more than just the outline. It actually contains everything that an instructor needs to teach a class, or at least that's the purpose of a curriculum. So I want to show you the curriculum of CISP 300 as far as ARC is concerned, and each college has its own, okay? And Sac City has CISP 301, okay, which is slightly different, but for the most part, the same stuff. This is the curriculum, because I want to show you, these are the learning outcomes and objectives. We have that in our syllabus already. Actually, I don't know, because I'm not teaching CISP 300. When you took CISP 300, did you read about the learning outcome and objectives of that class? Was it included in the syllabus? It's supposed to be. Whether you read it or not is a whole different story, but it's supposed to be included. Okay, so I want to, right here, just focus on one of the learning objectives. Construct a trace table to emulate the execution of a program that utilizes variables, control structures, data organization, subroutines, and parameters. That is what I just did. Okay, so this is supposed to be in CISP 300. Okay, the way it is presented may not be exactly the same as what I did, but it is supposed to be included. Sorry?
It's much simpler.
Much simpler. Okay. The point is, okay, many people come out of CISP 300 understanding, quote unquote, understanding subroutines. But if you cannot track recursion, you're not understanding subroutines. That's my take. Yep.
Is recursion used like all the time in programming, or is it just like some abstract kind of theory thing?
Both. Okay. Remember what I just said. Okay. If you think you understand recursion, take it back. If you think that you understand subroutines, but you cannot track recursion, you do not understand subroutines. So to me, it's a test to see whether people actually understand the mechanism of subroutines, which is very, very important. Yep.
Do you think you might be able to go into more detail about unwinding the stack and things that can go wrong with that? Because you mentioned it earlier in the lecture, and I was just trying to find stuff that talked about it, and I couldn't really find a lot of stuff that discussed that as a topic.
Well, we just did it in our trace, unwinding the stack. Okay, so let me just go back to the trace here. Unwinding the stack is basically crossing out stuff.
Yeah,
okay?
I get that. I mean, but what happens if you have a program? Because one of the things it mentioned is that if you have a go-to function or if you have a go-to statement within a function that goes to another function,
you
it
cannot
doesn't unwind the stack from the previous function.
No, cannot happen. A go-to cannot go to a label out of that particular subroutine.
What if it went to a memory address of a different subroutine that was
You
previously
cannot.
built?
In
You
C,
can't at
it
all?
is not allowed.
Okay.
Yeah.
So
there's no mechanism to do that.
But so there's no mechanism at all that would lead to portions of the stack just never being unwound and slowly compiling, like, or slowly accumulating in the stack?
Do you want the long answer or the short answer?
I'd be fine with the long answer some other time.
Sorry?
Like 5 minutes, so the short answer is probably the way to go.
Okay, the short answer is in CISP 400, you will be introduced to throw, catch, okay, try, throw, and catch. Okay, so those three types of statements are together allows you to specify a catch point. Okay, so you set up a catch point and say, okay, if something happens, I want to catch it here. Okay, but before you set up the catch point, there are two blocks. One is called the try block, and the other one is called the catch block. So try means, okay, go ahead and try to do something, that might end up with a big problem. Okay, end up, in a state where you cannot continue the operation of the program any further. And then the catch statement, which is in the same level, will say, if something really bad happens, continue execution in the catch part, so that I can at least do something, okay, maybe save a file before the entire program exits. So in the try block, you can call subroutines all the way down to whatever, okay? When you encounter a problem that you say, okay, I'm stumped here, I cannot continue execution, then you can execute what we call a throw, exception throw statement. And the throw statement will basically allow you to bypass, quote unquote, bypass multiple invocations all the way back to the catch point.
Okay.
Okay, so that's kind of doing what you seem to be suggesting, which is being able to jump from one particular invocation of a subroutine all the way to another point of another subroutine. So it's called a throw and catch approach. But that's in CISP 400, object-oriented programming.
Okay.
Yep.
Does the throw actually collapse those invocations?
Yes,
Oh.
it would collapse those invocations and it would actually do the right thing to clean up everything that is allocated along the way. And it does introduce all kinds of complexity because of that. Yep.
Are throws and catches just safety nets for when your program goes south, or are they actually used in the structure of programs outside of being a safety measure?
It is both. It's a general control mechanism, so people can use it for situations where you encounter a situation like 20 invocations down. You say, oh, okay, there's no way I can proceed at this point because of this really bad problem. But I know, so I'm gonna throw an exception. I'm gonna throw my hands and go like, I don't know how to deal with this, but somebody may. Okay, so if there's a catch statement catching that exception, then the program will continue execution at the catch statement. And then at that point, the catch statement can evaluate the situation and decide, well, should I exit or is there something else I can do at this point? So it's basically just a control mechanism, not necessarily handling just fatal stuff, but you can also handle minor stuff and go like, okay, we can continue, I just have to do these first. Yep.
So it kind of functions like a return statement in some ways?
It's like a super return.
Yeah, okay.
That's one way to look at it. But it's very object-oriented. So in CISP 400, you'll get the proper exposure and explanation of that. All right. So I think today we went over kind of really quickly, how to trace a program. And I'm really hopeful that, all of you understand what it is supposed to do. I don't need you to turn in the trace, okay? In other words, there will be no question whatsoever that I ask you to turn in this particular trace. But what I will do is to ask questions like in exam 2, where there are print statements, and you will have to indicate what the program is going to print. The ordering has to be right, and then the values of the print statements also have to be right. Okay, so that's the bottom line. I'm giving you the mechanism to keep track of the execution of the program, to keep track of the variables and whatnot, so that you can answer these questions or these types of questions. Is that okay? All right. Well, it's right on time. Okay. Wow, on the minute. That's rare. Yep. Go ahead.
Are there going to be like any questions where we actually write out the program, or are they all
I found that type of questions are very difficult to grade, so I try not to ask those questions. However, you might get a program where there are flaws, and I will ask you to fix the flaws.
With a conditional statement, if it's using a assignment statement as assignment condition,